In the previous video, we introduced you to the normal curve and variance and a little bit about the standard deviation. Now we're going to walk through an example of standard deviation with a sample. So here is the definition for standard deviation. Here is what I'd like you to write down, that first statement. What it does is it measures the deviation between each of the scores and the mean. And then if you want to write down more, you can. Not important if you want to just kind of listen and read through these. What it does is it gives us insight on how data is dispersed. The larger the standard deviation, the more spread the data is. The smaller deviation might indicate the data is stable or more reliable. That means there's little variation. Larger deviations tell us the data is volatile and unreliable. So here are some symbols that you might see in an IB class. There's some different notations. Mean, you're going to see this X with a bar. Please go ahead and write that down. Or in a population, you have this, it's called a mu, kind of looks like that. And then standard deviation, there's a couple different symbols. For a sample, it's S of n, and for a population, it looks like that. All right, so go ahead and write down this box so you know the notations. All right, I'm just going to go ahead, and if you want to pause and read more about standard deviation, you can do so. I just kind of highlighted on the previous slide for you. Again, here is another slide if you want to pause and read about it. Some examples of why we use standard deviation. All right, here is the formula I do want you to write down. Notice the word sample. So this is your formula for the sum of the variances underneath. We kind of talked about variance already. It's how much a difference from the mean, and we square it. And then it's n minus 1. Here is what each of the things mean. So pause and write down those items. And this is the formula. All right, this first example, I'm just going to walk you through it. If you want to pause and write it down, you can, and maybe just listen through this video. Here's the example. We want to determine the standard deviation from the following student test scores. So the first student got a 92%, then 66%, 99%, 75, 69, 51, 89, 75, etc. So what you do in your first column is you write down those scores. So your scores are going to go here. Then in the next column, you're going to calculate the difference from the mean. So before you can do the next column, you have to find the mean. So this is what's off to the side. This is the calculation for mean. Let me explain. The sum of x means this column right here. You added all those numbers up. So that's 784. And then you divided by 11. Why did you divide by 11? There was 11 scores. So your mean is 71.3. That's your average score. Now we're going to go ahead and calculate that. So this is the value minus the mean, the score minus the mean. So they show us this first one. So 92 minus the mean, and you get 20.7. And then you would continue doing that all the way through. So it does take a little bit of work to do this by hand. Then in the next column, you just square those numbers. So it is the value minus the mean squared. So you take 20.7 and you square it, and you get 428. You do that all the way through, and you get this cool number right here. This right here is what we call our variance. All right, so we're going to use that number in just a moment. So now we're going to head back to our side, and we're going to find the standard deviation. So remember, this is our formula for standard deviation. We're going to take this variance, and we're going to divide it by n minus 1. N, remember, is the 11 test scores minus 1. You're going to square root that answer, and you get approximately 17.26. This is your standard deviation. All right, so here's what this means. The standard deviation of the test results is approximately 17.26% away from its mean. Here's one more example. It's a little bit easier. They just kind of wrote it not in a column method, but they found the mean. Then what they did is they subtracted the mean and squared it right away and got that first total. Then they would add up all those sums and divide it by n minus 1, and you get 13.1. That is your sample variance. Then you use your formula. This one's a little bit different looking, it's the same thing, and you get 3.6, so the variance is 3.6. I personally prefer, when you do the standard deviation, that you just make the columns like you saw in the first example. I just wanted to show you a heads up because some students, when they do their internal assessments, want to do it looking like this second example.